Hello friends, today we are seeing what is the meaning of QuickSort. In earlier video, I will discuss about QuickSort, divide and conquer method and merge sort. Today I will discuss what is the meaning of QuickSort. Then what is the concept of QuickSort? Then the concept of QuickSort is here we are divided first the values means pick an element that is called P pivot element. Example, we are taking here first element is the pivot element. We can take any element here. This is question that what will be the pivot element? Then the pivot element will be any element of the array. It may be first element, it may be middle element, it may be last element, or whatever you want to take the pivot element. Then you can take the pivot element. Then partition. Here we are using partition algorithm, which divide the values less than P, that is first part, and greater than or equals to P, that is second part of the algorithm. Then recursively for sort first and second part. Here there is no need that the pivot element where position should be middle. It may be middle or not. Then combine the problem. What is the concept? How we can take pivot element? Then here we are taking pivot elements as the first element. What is the concept? Just send the P at its actual position. What is its actual position? That the element which is smaller than P is in first part, and element which equals to or greater than element than P, that is in second part. Then recursively solve the first problem and second part. Then list will be sorted one by one. And what is QuickSort? Here the algorithm of QuickSort. Here we are taking a left and right array. We are calling this array. What is the base condition over here? The base condition. The base condition first left is greater than or equals to right. Then return the value. Then what is the value of middle? We are calling here partition, which returns a position that is the middle. Then it means partition value is set. Then we call QuickSort again for a left to middle -1 because pivot element is in actual position. Then QuickSort will call for a left to middle -1 and middle +1 to right. Middle element is fixed, that is pure pivot element. Then what is the concept of partition? What is the meaning of partition? That let if I have P is pivot element, red color indicates greater element than pivot element, and here green color is represent a smaller element than P. Then what will happen? We are taking 3 pointers over here and compare to all the left and right values such like that. Here white pointer represents the left pointer and yellow color represent the right pointer. Then when left and right element crosses each other, then just switch first element to right position element to pivot element, and our concept will fulfill. Then example of partition, here we are seeing that if I have taking this array which have say 8 elements 4, 8, 6, 3, 5, 1, 7 and 2, then take first element as a pivot element, take two variables I is equals to 1 and j equals to 7, which indicates left and right pointer over here. Then compare pivot element as 7 position with right position element and compare it again with first left position element. Then what will happen? That here we are taking that compare 4 to jth position is 2. This is which is smaller than 4, and just hold it on position. Then again, because 4 is smaller than 2, 4 is greater than 2. Then compare it with left pointer. If this is swapping values, because 2 is less than 8, then swap the values, decrease the value of j and increase the value of k I. Then again compare it with 7. 7 is greater than 4, then reduce the value of j, and again compare with 1. 1 is smaller value, then hold it value j equals to 5. Again compare with I equals to 2 value, which is greater than pivot value. Then swap the value of 1 and 6. What will happen? When we swap the value of 1 and 6, then reduce the value of j and increase the value of I. Then again compare 5 to 4, which is smaller, then reduce the value of j, right pointer. Again compare j is smaller value, which is 3, and pivot value is 4, which is greater than j. Then hold it its position and compare it with 3. 3 means I equals to 3's position, value element is 3. Compare it 3 to 4, 3 is smaller value. Then increase the value of left pointer. Here, left pointer is closest to right pointer, means j have 3, which is less value than I. Then swap the value from right pointer. It means j position pointer, we will swap the value here. 3 to 4, swap the values, and our partition pivot element, its fixed position means smaller elements, which is smaller than 4, is in left hand side, and greater element, which is greater than, is in right position. Here partition, this type partition was when pivot is in correct position. And then algorithm. What is algorithm? When we are talking about partition, then take first element, a left is the first position p, and I left, j put the value of right. Here we are using repeat value, repeat I equals to I plus 1 until a of I is greater than or equals to p. Repeat j minus 1 until aj is less than or equals to p. This is comparing. If I is less than j, then interchange the value. We are discussing interchange in next slide until I is greater than or equals to j. This is the base condition. Then a left equals to aj and aj equals to p when at last position, and return the value of j at last position. Here interchange algorithm, how interchange algorithm works? Then take an temporary variable x, put the ai value in x, ai equals to aj, interchange the value, and at the position of aj, put the value from temporary variable. This is happening. This is how QuickSort works. Then this is the example. We are taking an example array A, which has 8 elements 0 to 7. Then what happened when partition will call? Then this is partition. What it returned? It will take 4 pivot as a pivot element and say, give it position, actual position. That's 4. There is 2 lists, 2 sublists, which is less than 4. That is meaning of a middle minus 1. Here, 4th position is middle. We are returning. Then algorithm partition, after partition, QuickSort is calling from A 0 to middle minus 1. Middle position is 4th. Then our array is calling from A0, 0, 2. A0, 2, 0, 1, 2, 3. 3rd position. Then what will happen? A QuickSort A02, again we are calling partition, which returns value of 2, then 1. This is the base condition. It return the value, again to 3, it returns value and return all the values. Similar thing is happened here. We are calling here. We are seeing that our list is already sorted 5, 6, 7, 8. But when we call the QuickSort, then partition will calculate at each position. That is the partition value, which gives 5. Then remaining value 6, 7, 8. Again, we will call QuickSort for A5, 7. Then what will happen? Partition, which gives the actual position of 6. There is nothing in left hand side, but there are 2 elements in right position. 7, 8. Again call 7, 8. This is the base condition. Return the value of 7, 8. Again, return the value of 6, 7, 8, return the value, and QuickSort is done. Then here, I have 1, 2, 3, 4, 5, 6, 7, 8, all the values. What will happen when we are talking about the base case and what is the average case of QuickSort? Then base case, when even partition is there, means when we call the pivot element or partition, and the value of partition is a actual middle of the array, then the partition is called even partition, and this is the best case of QuickSort. This is when we divided into half of list. This is similar to merge sort. Means n log n levels is there, and there is n comparisons in between all the elements. Then the time complexity is order of n log n. But when we calling about worst case analysis, then unbalanced partition is calling. Here we are seeing an example. This is in right position. That unbalancing is already sorted list is there, or we are calling the QuickSort again and again. Then this is the worst case. Then what will happen that I have to take n minus 1 comparison levels will be there, and n comparison with each element. Then the time complexity is n into n minus 1, that is order of n square. Then this is the time complexity of QuickSort. In worst case, there are two cases. This is a summary of QuickSort. Most of the work done in partition. Average case takes order of n log n time, and worst case take order of n square. But the important thing is there, the space complexity, which is does not require additional space of n or n by 2 size or anything. Then this is internal sorting. This is in internal sorting, and the time complexity of QuickSort is only constant time. Means only constant space will require for the algorithm. This is QuickSort. Thank you for watching. Thank you.